Hi folks, we're going to take a look at the solution to number 11 from page 74. So what they're asking us to do here is to find the equation of the line that's tangent to this function and parallel to this other line. Okay, so since we're looking for the equation of a line, we know that we need to find a point on this line and we need to determine the slope. Now we can actually determine the slope of this line because they're telling us that it's parallel to the given line here. Okay, so let's find the slope of that line. So we have x minus 6y plus 4 equals 0. So we'll find the slope by isolating y. Okay, so here, let me do it in a couple of steps here. So negative x minus 4. So y is equal to positive 1/6 x plus 4 over 6, which is 2 over 3. Okay, so I've just rewritten this equation in slope-intercept form so that I can determine the slope of the tangent. So slope of the tangent here is equal to 1 over 6. Okay? Now, essentially what we have to do is to determine what x value, okay, on this function has a tangent with a slope of 1 over 6. Okay? So essentially what we have to find is we have to determine which x value has a derivative, okay, which now we know refers to the slope of the tangent of 1 over 6. Okay, so this is what we're trying to find. So first thing we have to do is determine the derivative of this function and then figure out when that derivative is equal to exactly 1 over 6. Okay, and that'll then give us the point that we're looking for, because remember that a line that's tangent to a curve shares that point with the curve. Okay, so let's find the derivative of this function. Okay. Now here I have to find the derivative as opposed to derivative at a point because I don't know which point I'm looking for. Okay, so let's use our definition. So that's the limit as h approaches 0 of f at x plus h minus f at x over h. So now let's input what we have here. So here, wherever we see x, we replace it by x plus h. So this is the square root of x plus h plus 1. Minus the square root of x plus 1. Okay, and now we've seen this several times. Okay, we know that I'm going to multiply top and bottom by the conjugate. In fact, I'm tempted to not even write that out since we've done it so many times, but I will do it just in case some people are still struggling with that. Okay, sorry, the conjugate, so it's going to be plus square root of x plus 1, and of course the same in the denominator. And as is always the case, those middle terms cancel out, so I'm just left with this expression squared, which is just going to be x plus h plus 1 minus that expression squared. Okay, and again, please do not forget these brackets. Okay, and as we've done in the past, I'm not going to distribute the h because the idea is I want this to cancel out at some point. Okay, and now lots of nice stuff is going to start happening. So x minus x disappears, 1 minus 1 disappears. So the only thing I'm left with in the numerator is this h. Okay, so I'm going to be able to reduce this h with that h. So in the numerator at the end, I'm just left with 1. Okay, but more importantly is in the denominator, I now have no expression that approaches 0. So I can now determine the limit. So the numerator obviously just approaches 1, and in the denominator, what do I have? This just approaches x plus 1. So I just have root x plus 1 plus root x plus 1. So 2 times the square root of x plus 1. Okay, so this is the derivative. But what I now need to do is I need to determine when this derivative is equal to 1 over 6. So this is the equation I have to solve. Just do some cross multiplying. So 2 times square root of x plus 1 equals 6. So square root of x plus 1 equals 3. Okay, and now I can square both sides. Now notice here, by squaring both sides, I got rid of the square root. So when I actually solve for x, so I just end up getting 8, I need to make sure that 8 is in fact, in the domain of this function, and it is, there's no issue there. Okay, so remember sometimes when you get rid of a restriction, Okay, you need to make sure your final answer actually applies to the original function or the original expressions. Okay, so now I have the x value at which the derivative is 1 over 6, but since I'm actually looking for the equation of the line, I'm also going to need the y value, so y is just equal to square root of 8 plus 1, which is just equal to square root of 9, which is 3. Okay, and so now the slope is equal to 1 over 6. My point is equal to 8, 3. I can now determine the equation of that line. Okay, so again, use my trusty old y equals mx plus b. Now, I will be showing you very soon an alternative way to determine these equations with even less work. Some of you may or may not have seen it. We'll do that soon. But I'll just use this old-fashioned way. So y equals 3, m equals 1 over 6, x equals 8. Okay, so 3 is equal to, so 8 over 6 is like 4 over 3. And so b, I'll bring this to the other side and I'll change this to 9 over 3 so I can do the subtraction easily. Okay, so 9 minus 4 is 5 over 3. Okay, so the equation of my line is y equals 1 over 6, x plus 5 over 3. Okay, and there's my final answer. So quite a bit of work to do, but let's just recap, okay, what we're going to be working with here. So number one, to realize you were looking for the equation of a line, meaning you needed to find a slope and a point. The slope was gotten by the fact that it was parallel to the given line. Okay, so these types of questions are very common. I might give you one where it's perpendicular to a particular line, and you need to remember what that means in terms of the relationships with the slope. Okay, what I needed though was the point, so I needed to figure out when was the slope of the tangent equal to 1 over 6, and so that's why I brought in the derivative. Now here that took a bit of work because we had to determine this derivative function using the definition, and then from there we were able to solve for the point and determine the equation of the line. Okay, that's it for this one.